Hi, everybody. This is Dave Mariani. And this session is if your company isn't good at analytics, it's not ready for AI. So thanks for joining us today. And just a little bit about my background before we actually dive into this session. We'll leave a little bit of time for questions at the end. Um, I am currently the Chief Strategy Officer at AtScale. AtScale is a intelligent virtualization software vendor. The idea for AtScale, as a co-founder of AtScale, came really out of my work at Yahoo almost 10 years ago. So back at Yahoo, I ran data analytics and pipelines during the era where Yahoo was unique in that it was truly a big data vendor. Yahoo Labs, which was really one of the first majorly scalable data science organizations, was one of my chief customers. And I'll talk a little bit more about that in this session. So the idea for AtScale and for big data, really we pioneered at Yahoo by creating the Hadoop distribution and using that internally as a replacement for our data warehousing needs. So I'll be talking a little bit about in today's session about just what's happening here in the trends in data and analytics and how it relates to data science. You're going to hear a lot out there about data lakes versus data warehouses, and we're going to really dive into what those differences are and talk more about how they interrelate and how they work together. I'm going to present what I call the new analytics stack. And it's focused in the cloud, and it's a real game changer. So it's something when you're thinking about how to feed your models and get access to data to make good predictions. It starts with the right stack that will give you the right level of granularity and data access that you need to feed those models. And then I'll finish up with some recommendations for how to create a data strategy that's going to support all these efforts. So let's just talk a little bit about what's happening today. You probably have heard this and experienced it yourself, but most organizations today really have yet to really embrace data as a true differentiator. And these numbers are pretty alarming. But we've seen, even with our own customer base, getting real access to some of the best customers, especially in retail, is that we found that it's not just about creating and organizing data for your own internal use. It's really important to be able to create a self-service data organization. You hear that all the time. And there's lots of tools and software packages that say and purport to do that. But really, it really takes the right architecture to enable that kind of a motion. It's not about one software tool. It's not about one piece of technology. It really is having a data pipeline and data organization that's going to promote self-service, but self-service with the proper amount of governance and safety. You think about competing on analytics. Today is obviously trying times. And when you look at what's happening in retail during this crisis, it's very obvious that the just-in-time inventory chain is really not working out so well. And a lot of that is really due for the fact that it's all driven by data. And the retailers that are trying to manage that data and trying to manage inventory across their stores and across their digital presence by themselves are having real difficulties. So we've seen some retail customers of ours who share that data with their vendors and their suppliers. So if you think about that, that allows those retailers to distribute out that supply and supply chain management beyond their own doors and their own employees to their partners and their vendors and their suppliers. And it is in their interest, their suppliers, to make sure that goods are on the stores and the proper stores in the right areas and online digitally so that they can maximize their profits. So it's not just about creating a data strategy for yourself. It's about creating a data strategy for your customers and your partners. And I think that is going to be the next wave of how customers and how enterprises truly differentiate themselves and set themselves apart using data. So what happens when it comes to data science? You've all probably heard and seen these kinds of statistics before, but it's about access to data. And most of the time, a data scientist or a knowledge worker is spending time wrangling data and transforming the data to make it consumable, if they can even find it at all. It really hurts and pains me to see people working with files and using files to actually feed models and do analysis. That really is very ancient if you think about it, given all the digital assets and all the technology we have to make that data available in a form other than files. When I was at Yahoo, we had thousands of data scientists that I supported in Yahoo Labs. And in Yahoo Labs, the chief complaint was, we don't have access to data. We actually created Hadoop and invented Hadoop to actually solve that problem and give them access to data. But their chief complaint never changed. It still was, we need access to data. And what we found was it wasn't about just making a data asset available. It meant putting in the structure and the semantics and the metadata and the access paths and the governance and security paths, so that those data scientists could self-serve, and they could self-serve and find the data they needed to use and feed their models. So that's what I'm talking about here, and that's what we're going to talk about a little later on. It's about some of the techniques and strategies that you can use to really deliver on that self-service promise. So let's first look at some statistics. We recently ran a survey, and in this survey, we asked some questions to a bunch of cohorts in data engineering, and we asked this question: which AI ML tools were in use by your organization, both today, which is the green bars, and the future, which is the red bars. And you can see that predominantly it's about Spark, which really says to me that we're still in a world of bespoke. We're still doing it ourselves. You still no one application that's really dominating the landscape. So it still is up to us using the open source tools. You can think of Databricks as being a commercial offering around Spark to be able to get access to those tools. So we're still dealing in a world where we're not quite organized in a way that we could use tools to help us with these tasks. The other thing that was very illuminating, not surprising though, is that these respondents were really already in the cloud. So 61% were already in the cloud, and if you look at that in terms of the ones that weren't in the cloud but what they were planning on doing, you can see that 84% were planning on going to the cloud. So if you haven't heard, I'm sure you have. If you're not thinking cloud, you're behind, and you really need to consider what your strategy is to modernize your data infrastructure. Here's a little bit more data, which is interesting, which is what are the main workloads that our customers are using the cloud for. Well, you can see that of course respondents really were looking to the cloud to help with flexibility and being able to consume and pay for what they consume for. You can see lower the cost is 67%. That unfortunately doesn't really happen very often. If you're moving to the cloud, you're not likely to see cost savings at all. You're definitely going to see flexibility. You're definitely going to see consumption for what you pay for. But if you're successful, your costs will actually go up because you'll be promoting more usage within the organization. But of course, data science and analytics and better analytics is really the third most outcome sought by moving to the cloud. And you can see that data science is the predominant workload that is being deployed in the cloud. So definitely a trend's developing here. But the cloud, moving to the cloud, really means a retooling and a replatforming. And so there's a lot of things to consider when we're moving to the cloud, which in one big consideration is really when it comes to data governance and data science and data security. You can see some pretty staggering numbers here in terms of the types of risks that you have about exposing data to those who shouldn't have access. And of course, this is not just about the cloud. This can happen even within the firewall. But obviously, when you put it into the cloud, your risks go up pretty dramatically. In our survey, we found out that 80% of the organizations that we queried were looking at data governance as their top challenge. That's a lot of anxiety happening. So in this new architecture, in this new cloud architecture, we have to assume that it's not just about agility and access to data. It also needs to be some pretty stringent controls put in place at ground zero as you architect this new stack to make sure that you can scale out and truly create a self-service organization. So just summarizing some of the trends that we're seeing with our customers, we're seeing every single one of our enterprises is looking to the cloud for analytics. If they're not already there, they have a plan to get there. The days of the on-premise data lakes like Hadoop or data warehouses like Teradata are really over. There always will be a presence of those technologies on premise because it takes a long time to move off of them. So not only do you have to consider your data in the cloud, you also have to consider that you will still have data behind the firewall, and that in itself creates a big problem that we'll talk about in a little bit. And machine learning and AI still not fully scalable yet. I think it's still a bespoke DIY kind of effort, and I'm really hoping that we see some real automation here to really see an explosion of AI and ML like we did with business intelligence in the last decade. So what are we going to do to resolve some of these problems? How do we create a self-service data infrastructure? How do we create that self-service data infrastructure with the right data governance and security access? How do we make it scalable so that we don't have to pick and choose what data is worthy for analysis? How do we promote the use of that data and consistently, whether it's being consumed by AI or ML platforms or data scientists, whether it's consumed by business analysts with their BI tools, or whether we're consuming it with custom applications? How do we ensure there's semantic consistency across all those different consumers? Well, the vendors out there definitely have an opinion on the way you should go. So what I'm going to do now is talk a little bit about a couple of those opinions. One being first the data lake, and second being the cloud data warehouse. So I'll take a couple examples now. So let's talk about Databricks. This is an excellent blog post that Databricks put out. It's called "What is a Lakehouse?" It's the term that they've coined. And you can see in the Lakehouse, they sort of take you through the transition from the original data warehouse to the emergence of the data lake, primarily Hadoop, which is what I experienced almost 10 years ago now, to what they're calling a data lake or lakehouse that obviously is supported by Databricks. So what you can see here in this picture is it's very clear that data marts were always sort of the intermediary between the raw data and the operational data and the actual analysis itself. starting with the original data warehouse. And data warehouse, we mean data marts, not just data warehouse. You can see that when I was at Yahoo introducing the data lake, we still had those data marts and data warehouses. For Yahoo, it was Oracle. I still had to move mass ETL to be able to extract data off of the data lake because it wasn't consumable here because it was too slow and not really consumable by the BI tools. And we had to pipe that back into Oracle or back into static cubes to support these workloads. And then the machine learning and data science came straight off of the lake, but with tools like MapReduce or a very early Hive, made it very difficult to actually consume that data at scale, given that it was just really not a data lake, more of a data swamp. So the lakehouse approach says that, hey, we can take and use this data lake, but we can now use this data lake to support multiple workloads, including business intelligence, as well as data science and machine learning. So you can see that it eliminates the data marts altogether. So again, this is a blog post that was just released probably in the last 60 to 90 days, so fairly recent. Now, what about the cloud data warehouse? The cloud data warehouse, examples of the cloud data warehouse include Google BigQuery, Amazon Redshift, Azure Synapse, and Snowflake. So let's look at Snowflake. So this is Snowflake's approach and their approach to a data architecture. And you can see this looks very much like the traditional approach of a data mart, where you have your operational data sources using ETL to stream into a set of data marts, which then can be consumed by the business. And you can see that they have the data science actually consuming out of the data mart, as opposed to dealing with, there is no data lake in this picture. It is in a Snowflake enterprise data warehouse. That's very much like a back to the past, back to the future kind of a architecture, right? And very, very different from Databricks Lakehouse approach. So those are two very different versions of data architectures in the cloud, aren't they? And you have to wonder, with those types of extremes and very well-funded startups promoting those extremes, what's that really mean for you? What do you do? Do you use a data lake and you base everything on a data lake, or do you use a data warehouse? And the answer really is you use both. And really, if I've learned anything over the years of being in this business and in creating data pipelines and data assets for consumption by the business, it's that you got to use the best tool for the job. So if I were building my own analytics stack today, it would look something like this. And so let's take this apart for a second. Well, what you see here starting at the bottom is that, of course, you got to have a landing zone for your data. That's the data lake. If you're in an Amazon cloud, that would be S3, and that would be an S3 data lake. If you're in a Microsoft Azure world, that would be ADLS. It would be Google Cloud Storage if you were in the Google Cloud. Whatever it is, you're going to want to be able to land that data and land that data as is, as data files into that data lake as is, and capture everything. Don't throw anything away. Well, then you can see you may want to feed a data warehouse. And that feeding that data warehouse probably is going to be through your traditional ETL or ELT engine. There's also file access engines, which I'll talk about in a second, that will allow you to actually consume straight off of that data lake. And that will allow you, especially when you're feeding your data science models, allow you to get off the kind of raw access you need to be able to train those models. You notice there's a new layer in here, and this is the semantic layer, or what I call the governance engine, the semantic layer. So without this semantic layer, without sort of having one gateway, you could see that it might be data chaos. So if you had data in your data lake being consumed and in your data warehouse being consumed, but you had no way of defining those relationships or governing their access, then you can clearly see that you could get different answers. Your data warehouse may be great for clean data, your data lake may be great for raw data, and you need access to both. And you need to be able to consume with a number of different types of applications, whether it be your BI tools like Tableau and Looker and Power BI, your AI and ML tools, as well as your custom applications. And a data catalog is great for keeping track and cataloging what these different assets are. But they don't really do anything when it comes to enforcement of data policies. So while tools like Calibra, for example, may be able to set data policies, they don't actually apply those policies at the application level. And so it's up to each and every application to embed its own security and access protocols, which really makes life very hard to manage for an IT organization. So if you wanted to create a architecture like this, what's this give you? Well, it gives you one control plane for data access. It gives you the best of both worlds. It gives you a high performance cloud data warehouse for the data that is been polished and normalized. It gives you access to the raw data so you can feed and access and explore data to see if it's worthy of being normalized. And you get to actually keep track of where the data is and who's using it using your data catalog tools. So if you were to put it all together, here's some of those vendors that might fit into these categories. Again, you have your file systems. This is going to be based on your cloud. You have both old and new ETL tools from using traditional Hadoop as a data pipeline to using tools like Talend and Matillion, which are more ELT kind of tools. You have your choice of cloud data warehouses. They're all very good. So I encourage you, if you want to find out more, we've done some benchmarks and studies against the different types. You can come to atscale.com to see that data and those benchmarks. The file access systems, you can use Spark to get access and put a SQL interface directly on S3, for example. Or you can use Amazon Athena or Amazon Spectrum, or use plain old Hadoop to get access to that file system. You can use a virtualization layer and a semantic engine from AtScale, Dremio, Denodo, and Muta. There are a few out there, which will give you that control plane for plugging those applications and those consumers into. And of course, you have your data catalog vendors who can sort of keep track of these data assets as they move through the pipeline. So those are some of the options for creating this new data stack. I really think that this gives you the best of both worlds. It gives your reporting and BI tools access to the clean and blessed data that they need. It gives your data scientists access to the operational and raw data that they need to train and build their models. It gives your applications and custom applications access to either, so that they can create automation, do personalization, and deliver great customer service using data at any needs. The key here is to have that semantic layer, though, so that you can have that governance and that single control plane, so that you can make all that data behind that firewall, essentially that data firewall, managed and accessible for self-service. So just to finish up here, some of the considerations for that you should keep in mind as you look to modernize this stack for your data science needs. First of all, rethink everything. You don't want to be taking your on-premise data platforms into the cloud with you. That's in general a very bad idea. And make sure that as you bring those, as you reevaluate your data stack, test. Don't believe what the vendors say. You need to actually prototype and try and move and try these new workloads using a variety of different tools. Our customers who have done that have been the most successful because they've really reduced the amount of gotchas and surprises that they discovered as they make those motions. There is no magic bullet. There is no one software to do it all. Don't believe the vendors. Use a data lake, use a data warehouse, use them both because they serve different needs. And make sure that if you can avoid at all, don't get locked into the clouds and your cloud providers' proprietary tools. That's the way that they lock you into their cloud. Make sure that you choose tools that will work across any cloud so you have the flexibility of moving or using multiple clouds when necessary. And don't think that you're going to save money. If you're successful, it's going to cost you more because you're going to drive consumption, and that consumption is going to be priced by the byte. So if you're successful, your costs are going to go up, not down. You will definitely get flexibility. That flexibility means that if you don't tightly control it, you're going to have unpredictable costs. So make sure that you have that control plane and you have that architecture such that you can manage those costs and make those costs predictable. So that is that's really the end of my presentation. Let me see if I can see if there's any questions from the audience. And let's see in the control panel here if I can see if there's any questions.
Hi, I think there are no questions, so we can close the session over there.
Okay, thank you everybody very much for presenting, and sorry for attending, and hope to see you soon at future conferences. Thank you.
Thank you so much.